All right, my dears. I want to make sure that that you're drawing your Lewis dot diagrams for compounds correctly. I want to let you know that it is completely reasonable and understandable to take to do this work on paper. I find chemistry incredibly difficult on a screen. I strongly encourage you to use paper and just take a picture of your work and send it to me that way, because it's really hard to see. You guys got really creative, and I'm impressed at how you drew your Lewis dot diagrams for your individual atoms, but it's tricky to do it with compounds if you're not using a paper and some kind of pencil or pen or something. So feel free to do that. I think that between the two videos there wasn't quite enough information, or you just need to hear it again. So I'm gonna go ahead and go through how to draw Lewis dot diagrams for compounds. If I were taking this class, I would be writing this down in a notebook somewhere, because that's the way my brain works, is to write things down and then it sticks in my brain better. So you might want to try that. So Lewis dot diagrams, the way to do it, the first thing that you're going to do is you need to count up all of the valence electrons that you have. Okay, so if we're going to be looking at, if we're going to look at something like, let's say phosphine, where we have pH3, I'm going to look at P, and I can see, well, let's not use those dots because that's a little bit confusing. So P has, it's right down here. Phosphorus has, it's in the 5th family. So if we count over, there's 1, 2, 3, 4, 5. So phosphorus has 5 valence electrons. And this 3 right down here is like in math. It relates to the element just to the left. So this 3 means that I have 3 hydrogens. So that's kind of what that means. So it means that I have H, and H, and hydrogen is over here, and it only has 1 valence electron. So it only has 1 electron total, right? So 1 electron there. So I have hydrogen with 1, and I've got 3 of them from this 3 right here. Okay, so if I'm going to add them all up, I have 1 times 3 is 3. 3 plus 5 is 8 total valence electrons. So anytime you see that you have 8 total valence electrons, you can be pretty certain that it's going to be a simple Lewis dot diagram, not too tricky. So then the next step is to draw Lewis structures for each individual atom. So you're going to draw a Lewis structure for each atom. So if we have 1 phosphorus, I know that it has 5 valence electrons because it's in this 5th family over here. So I'm going to start at the top and go around. 1, 2, 3, 4, 5. So this phosphorus has 5 valence electrons, and then I have 3 hydrogens. So I'm going to draw an H and an H, and it has hydrogen. I've got 3 hydrogens. Each has 1 valence electron. So if we look closely at this, once you've got your Lewis structures for each atom, take a look and see how many places they're willing to form a bond. So my phosphorus has this up here. Oh, that was an eraser. That's not what I wanted to do. Ah! There we go. Goodness. So this phosphorus, right up here, this is what we call a lone pair, or a pair of electrons that are unbonded. They're all alone out in an orbital there. And this wants to make a bond here. There's a spot for a bond here and a spot for a bond here. So the phosphorus has 3 places for bonds. Because remember, according to the octet rule, the phosphorus would like to have 8 valence electrons to complete that the total energy level of the highest energy. The hydrogens, you can see, have a spot for a bond. Each hydrogen wants to make one bond. So you've got hydrogen, remember, is in the first period, and it only wants 2 valence electrons. I can't spell. It's really kind of problematic. Or use this iPad. So it has 2 valence electrons that it wants in its outer shell. And if you look at this, the next step that you need to do to draw your Lewis dot diagram is to take and put the atom with, nope. You put the atom that needs the most bonds in the center. And one thing to be sure that you remember, I don't know, it sticks in my brain, is that chemistry really likes symmetry. So if you take a look at this situation that you've got here, you've got each of these 3 hydrogens want one bond, and if you look, you can sort of tuck them in. So this guy, whoa, why is it making a straight line? I don't want it to do that. You can put this one in right over here. You can put this guy in right under here, and you can put this one in right here. So it's pretty easy to see how you can put the phosphorus in the center, give it its 5 valence electrons, and then you're going to surround the center atom with, you're going to surround the central atom with whatever you have. And remember that chemistry likes symmetry. Okay, so you're going to take your phosphorus and you actually, instead of drawing a Lewis dot diagram for it, sometimes it's a good idea to just draw what we call a skeleton. So you're going to put your thing in the center that has the most outlets. Phosphorus has 3 places for bonds. So we're going to put phosphorus in the middle, and then we're going to connect it to the hydrogens with single bonds. Okay, so 5, connect with single bonds. And we remember that each bond counts for 2 electrons, right? So there's 2 electrons here, there's 2 electrons here, and there's 2 electrons here. So you're going to connect it with single bonds, and then we got to do some electron math. So each bond counts for 2 electrons. Each bond is 2 electrons, so you're going to add up how many electrons you used and subtract from what you had. Add up electrons used in bonds and subtract from what you had to start with, from your total valence electrons. So if you look at the total valence electrons that you have to start with, remember you have 8 valence electrons up here to start with, and you, just a second, my people are talking. All right, I'm back. So you are going to, oh yeah, remember that we have 8 total valence electrons because phosphorus has 5 valence electrons. I have 3 hydrogens, and each of them has 1 valence electron. So 5 plus 3 is 8. So I had 8 valence electrons to start, and I used 6 because I had 2 from each bond, and I have 3 bonds. So 6 from the bonds, and 8 minus 6 is 2 left over. Okay, so each bond is 2 electrons, so you're gonna add up the electrons used in the bonds and subtract from the total valence electrons. And then any leftover electrons go on the central atom. So I have 6, I've got 2 left, and so I'm going to put them up here on the phosphorus, and that that uses up all of them. So now I've subtract my 2 from the lone pair, and that means that I've used all of my valence electrons, which is what I want to do. Okay, so you're going to use the leftover electrons go in the central atom, and on any other atoms to complete their octets. Okay, the next thing that you need to do is check. Check to see that all the octet rules are followed. So check to see that the atoms all have full valence shells. Sorry, my family's talking again. This is what happens when you're trying to teach in your living room. Okay, so if we look at, I'm going to redraw it down here so we can see it. We've got phosphorus in the middle. It's got a single bond to its 3 hydrogens. Remember, we're drawing pH 3 right here. And if we look at this, I've got 2 electrons right here for this hydrogen. There's 2 electrons here, 2 electrons here, and 2 up here. The cool thing about this is anytime you've got a bond, those electrons get to count for each of the atoms. So if we look at the hydrogen can use those electrons. So this particular hydrogen has access to 2 electrons, so it's happy. This electron right here, oh, nope, that went to an eraser. Stop it. Didn't do any damage though. Okay, so this same thing right here. This hydrogen has access to the bonded electrons. So this one also has 2 electrons right here. It's happy. It has a full, its valence shell is filled with electrons, and it's energetically favorable. Same thing up here. This guy has access to these electrons. It also has 2. It's good to go. Now, I'm going to erase those. Well, no, I'm not. I'm going to do it in a different color. So you can see this phosphorus now. It has these electrons up here. That's all for itself. And then it's also sharing these electrons with the hydrogens. So if we look at this phosphorus, we've got 2 electrons here. We've got 2 electrons here. We've got 2 right here. And we've got 2 right up here. So it has 2, 4, 6, 8. So the phosphorus also has 8. They're making coffee. They're having conversations. This is our world, people. So in this instance, all of the octets are satisfied. Everybody's valence shell is filled with electrons. It's energetically favorable. That works. I hope that this helps things make sense a little bit more. If you have specific questions, please ask. And remember, anytime you're doing, I'll do that in a different video. I'll make another video showing how to do organic compounds where you have oxygens or carbons bonded to other carbons. All right, thank you, my dear.